Hi students, today we will continue with your topic thermodynamics and this is your sixth lecture. In last lecture we have discussed about thermodynamic processes and we have studied reversible and irreversible process, isothermal process and isobaric process. In this lecture we will start with the isochoric process. Isochoric process is the constant volume process, or you can say delta V is equal to 0, or you can say change in the volume of the system during this process is 0. That is, if system is changing its initial state from A to final state B. During this change of state, volume of the system is constant. As you can see from the graph, Vi is the volume of the system which is constant throughout, but pressure is changing, that is from Pi to Pf. Here Pi is the initial pressure of the system and Pf is the final pressure of the system. If volume of the system is constant or change in the volume of the system is constant, then there is no work done. Means what? Work done by the system on its environment during this process is 0. So, what will happen? All the energy which we have added to the system is used to change internal energy of the system. For example, you can take heating of gas at constant volume container or diffusion of gas in closed chamber. If you heat the gas in constant volume container, then what will happen? Volume of the gas will not change, temperature will change, pressure will change, but there will not be change in the volume of volume of gas. If volume is not changing, then there will not be any work done by the gas on the system. By the gas on its environment. So, whatever the energy we will provide to the system is used to change its internal energy. If system gains energy, then there will be the increment in the internal energy of the system. If system loses its energy, then there will be the decrement in the internal energy of the system. But there is no piston or anything which is displaced by that system. So, there is no work done. So, according to first law of thermodynamics, this is the equation of first law of thermodynamics, that is Q is equal to delta U plus W. But you are knowing this work done by the system or on the system is what? System does no work on its environment. So what will happen? W is equal to 0. So Q is equal to delta U. That is what I am saying, that whatever the energy or amount of energy is given to the system is used to change internal energy of the system. And you are knowing that equation of internal energy is equal to the NCV into delta T. CV is what? Molar specific heat of the gas when its volume is constant. So Q is equal to NCV into delta T. Okay, this is all about isochoric process. So we will start with the next, that is adiabatic process. In adiabatic process, there is a no transfer of heat from or to the system. Means what? There is a no heat exchange. Means what? Q, amount of heat is added to the system, or amount of energy added to the system or loosed by the system, is equal to 0. Then heat exchange हम कैसे prevent करेंगे? We can prevent heat exchange by providing insulating wall between system and its environment or surrounding, or you can say by carrying out the change rapidly. इंसुलेटिंग वॉल अगर आप यूज़ करोगे, जैसे एग्जांपल ले लो थर्मास फ्लास्क, उसमें आपने कोई भी लिक्विड अगर उसमें पुट किया तो क्या होगा? हॉट वाटर आपने डाल दिया थर्मास फ्लास्क में, सो व्हाट विल हैपन? इट विल नॉट लूज इट्स एनर्जी विद द सराउंडिंग. इट इज़ बिकॉज थर्मास फ्लास्क के जो वॉल्स होते हैं वो क्या होते हैं? इंसुलेटिंग वॉल्स होते हैं. तो इंसुलेटिंग वॉल से कोई भी हीट और एनर्जी एक्सचेंज नहीं होता. और यू कैन से by carrying out change very rapidly. If change is happening very rapidly, then what will happen? There will not be any exchange of heat with the surrounding. Then इसका एग्जाम्पल है puncturing of an inflated balloon. Okay, if Q is equal to 0, means amount of heat added or removed from the system is equal to 0, then according to first law of thermodynamics क्या इक्वेशन है उसका? Q is equal to delta U plus W. It's Q is equal to 0, then what will be the equation? Delta U is equal to minus W. Means what? Change in internal energy is equal to minus of its work done. मतलब अगर work done, internal energy decrease हुई, work done increase होगा. internal energy increase हुई, work done क्या होगा? decrease होगा. Means you can see here, when expansion of system takes place adiabatically, मतलब किसी भी सिस्टम में कोई भी सिस्टम है adiabatically चेंज हो रही है, then what will happen? Work is positive and delta U is negative. When expansion of gas, if you take the example, there is some expansion of gas takes place, then what will happen? Its volume, when expansion of gas takes place, its volume increases. If volume increases, there will be the positive work done, and internal energy of system get decreased. We have seen this in the sign convention of work done. When system compressed adiabatically, then its volume decreases, work done is negative and delta U is positive. Here work is done on the system, so internal energy of the system increases. For many systems, if temperature of system increases, its internal energy increases. temperature of system decreases, its internal energy also decreases. Now for adiabatic process, this is the equation of state, that is PV raised to gamma is equal to constant or is equal to C. You can say this is equation number 1. Here gamma is what? Cp divided by Cv, which is equal to adiabatic ratio. Here Cp is what? Molar specific heat of gas at constant pressure, and Cv is what? Molar specific heat at constant volume. For moderate temperature, value of gamma is equal to 5/3 for monoatomic gases. For diatomic gases, gamma is equal to 7/5, and for polyatomic gases, gamma is equal to 8/6, or you can say 4/3. Now we know that for adiabatic process, heat exchange, that is Q is equal to 0, or you can say that system is isolated from its surrounding or environment. So when system undergoes adiabatic change, then its temperature and internal energy both changes. You can take example, puncturing of inflated balloon. Here high pressure air rapidly come out from the balloon. Here जो भी air उसमें से बाहर आएगी, that will get cooled, hence its internal energy will get decrease. Here there is no exchanges of heat with the surrounding. It is because this process is happening too much rapidly. So change in internal energy of the system is given by the equation delta U is equal to Cv into delta T. So work done of the system you can calculate by the equation W is equal to V limits of integration Vi to Vf P into dV. Now from equation 1 you can put value of P, that is P is equal to C divided by V raised to gamma. So you can put that value of P in equation of work done, then your equation will be W is equal to C into, C is a constant, it can come out from the integration, then integration of Vi to Vf dV by V raised to gamma. If you solve this integration, you will get the equation of work done as W is equal to C divided by 1 minus gamma under root 1 upon Vf minus Vf raised to gamma minus 1 minus 1 divided by Vi raised to gamma minus 1. Now again in equation 1, P V raised to gamma is equal to constant. Then we can write Pi Vi raised to gamma is equal to Pf Vf raised to gamma is equal. Pi is what? Initial pressure of the system. Vi is the initial volume of the system. Pf final pressure of the system. Vf final volume of the system. Or you can say PI, VI is the pressure and volume of initial state of the thermodynamic system, and TF, VF is the pressure and volume of the final state of the thermodynamic system. So we can write here C, you can take inside the bracket, and instead of C you can write PI VI raised to gamma and PF VF raised to gamma. So by solving this equation you will get W is equal to 1 divided by 1 minus gamma PF VF raised to gamma minus PI VI raised to gamma. Now from ideal gas equation, here knowing that PV is equal to nRT. So instead of PF VF raised to gamma you can write TF, and instead of PI VI raised to gamma you can write TI, and nR is the common factor. So equation of work done will be W is equal to nR into bracket TF minus TI divided by 1 minus gamma, or is equal to this PF VF raised to gamma minus PI VI raised to gamma divided by 1 minus gamma. Then from above equation you can see that when work done is greater than 0 and Ti, that is initial temperature of system, is greater than final temperature of system, gas will cools down, and here gas will expand. And when work done is less than 0 means negative, here temperature of initial state of the system is less than final temperature of final state of the system. Here gas will warms up, means that there will be the compression. In first case there is a work done by the system, and in second case there is a work done on the system. Then next thermodynamic process is cyclic process. Here a thermodynamic process that return a system to its initial state is called as cyclic process. You can see in the graph that process is cyclic, that system goes to A to B. If A is the initial state of the system, B is the final, then path first is system is changing itself from A to B, and path 2 shows system changing itself from B to A. That is initial and final state of the system is the same. You can say A is the initial as well as final state of the system, and B is what? Intermediate state. Total change in internal energy is 0. Means if system is changing itself from A to B, then there will be the change in the internal energy. If system changes from B to A, there will be again change in the internal energy. But totally क्या होगा? सिस्टम वापस घूम के ए से ए वापस आ रहा है, तो टोटली आप अगर देखोगे तो क्या होगा? सिस्टम को बाहर से देखोगे तो आपको क्या लगेगा? देयर विल नॉट बी एनी चेंज इन द इंटरनल एनर्जी ऑफ द सिस्टम. Then according to first law of thermodynamics, Q is equal to W. अगर इंटरनल एनर्जी 0 है, चेंज इन इंटरनल एनर्जी 0 है, then amount of energy added or removed from the system is equal to the work done by or on the system. Now we will see the free expansion. Here free expansions are adiabatic expansions where there is no exchange of heat between the system and its surrounding or environment. So there will not be any work done on or by the system. So Q and W is equal to 0. Q means what? Amount of heat added or removed from the system, and work done by or on the system is equal to 0. If both the things are 0, then delta U means change in the internal energy of the system is again 0. So here example is inflated puncturing of balloon. ये हमेशा मैंने आपको एग्जाम्पल दिया है. यहाँ पे होता क्या है, एयर रशेस आउट रैपिडली फ्रॉम द बलून. There is no displacement of piston or any other surface. If displacement is not there, there will not be any work done. हमने कोई एनर्जी प्रोवाइड नहीं की, ना कोई एनर्जी रिमूव की from the system. So Q is equal to 0 and hence there will not be delta U is also 0. So this expansion is uncontrolled change. That is, free expansion is uncontrolled change. Free expansion is an instantaneous change and the system is not in the thermal equilibrium. So this is all about your thermodynamic processes. Syllabus of your thermodynamics is up to this point, free expansion. For this year, that is 2020-2021 academic year, your syllabus is up to free expansion. After that, there will not be any topic is included in your syllabus. That is from 4.8 heat engines up to 4.12, that is Stirling cycle. This part of your syllabus is not included for this academic year. Means this syllabus is reduced from your topic thermodynamics. Okay, so up to free expansion, your syllabus, whatever we have discussed, that is in your syllabus, and after that there will not be any part which is included in your syllabus for the academic year 2020-21. Okay, so this is all about your thermodynamics. One lecture is remaining for your problems, or you can say numericals. Then I will upload that numericals in next week. So till then, thank you.